All right, here is a possible couple of examples of problems that we want you to go over that could possibly be on your exam on Friday now. Again, all of you are watching this now because we are gone to Freeman, and then with the understanding some of you are gone on Thursday for land judging for your agricultural class. All right, so as we look at this, if two students were in a competition and we're running towards each other, okay, or you could say it's not necessarily that they're in opposite direction, but one is moving east and one is moving west, what is the conservation of momentum? Okay, so the one that's running to the east is moving at 3.10 meters per second and has a mass of 85 kilograms. And the other student is running west with and moving at 4.35 meters per second and has a mass of 110 kilograms. I want you to be able to describe what the momentum is of each student and then what is left over for the conservation of momentum. That's the problem written in blue, and then for the problem in, or below that, written in the brown color. To complete an experiment, a student needs to determine the height of a building. How can that be done approximately with a rock and a stopwatch? Okay. In this case, again, this is just approximate. This is not like this is going to be an exact amount. If they determine the rock hits the ground 5 seconds later, how high is that building using the, and accounting for gravity or using the variable gravity? So I'll let you go ahead and work through those problems while I hit pause, and then you can go ahead and come back and we'll see if we're understanding these. Again, this is for your exam on Friday. Okay, so as we continue, we gave you a chance to go ahead and write those problems down. And I'd like to think that if you're working on these, that you'd work through them and then see if you get the same answer. Or if you're more comfortable with just following along, whichever works for you. Just like any other problem that we've done in the past, the first thing that we want you to do is write down the information that you know in this case. And here we have 4 variables. We got 2 velocities and 2 masses. So maybe the best course of action is to do as follows. We'll just say we've got student A, okay, that has, and it doesn't matter which one you pick, but since we've got one student running east, okay, student A is running east, so we'll just do this and say our velocity is 3.1 meters per second and has a mass then of 85 kilograms. Okay, and then we've got student B here that is moving west. Okay, that also has a velocity, or is moving at 4.35 meters per second and has a mass of 110 kilograms. What is each momentum? So that is what we are solving for. Nothing new there. Okay, so we've got this one moving east, and then this one, or this student, is moving west. Okay, so just like any other momentum problem, you have to know at least 2 of the variables, and we do. So do what the formula tells you to do, and that is our momentum then equals our mass times our velocity, 85 times 3.10. We would do the same thing over here. P equals 110 times 4.35, and get what our momentums are. Okay, so 85, doing what the formula again tells us to do, 85 times 3.10, that gives us 263.50. Again, that's kilograms dash meter over second, or seconds. And then over here, we've got 110 times 4.35. That gives us 478.50 kilograms dash meter over seconds. But remember, this is a conservation of momentum. And here in this case, student B has got a larger momentum. So we've got 478.50, and we've got 263.50. Go ahead and subtract those. And here we get 0, 0. And in this case, we get 5, 1, and 1. And some of you are more comfortable doing it this way, 478.5 minus 263.5, and we get 250. Oh, geez. 2 from 4 gives us 2, not 1. So 215 kilograms dash meter over second. So which way is that moving? Okay. It's moving to the west, okay? Moving, so we have this much moving west. That's fine. We want to be able to account for what's left over. 215 kilograms per meter per second moving to the west, because that's the direction that this student is moving. We know that student B, and they're moving west, and that's where that comes from. 215 kilograms per meter per second moving west. All right, so that is our top problem. Go ahead, and at any time, if you don't want to see any of this erased, you could, or don't have it wrote down, you can always go back or just hit pause. Okay, so that is one problem. Okay, so then on this bottom one, it may be such an aspect. Remember, this is a vertical component, so you have to account for gravity, and that's what it's saying there in the last portion of this problem. So completing this experiment, we want to see, well, how tall approximately is that building. So with this information that we know, we're going to start with gravity here, which is a known value. So that acceleration due to gravity then is 9.8 meters per second squared. Okay, so starting with this rock, you're holding over the edge of the building, so it's not going to be moving. Here's our rock that we're going to let go. So since it is not moving, 0 meters per second. And how long did it take for that rock to reach the ground? So in this component, we see we've got approximately 5 seconds. So then what was the final velocity? Notice that's not giving us the height. That's just a part of the component to calculate what the height would be. All right. So with this, now that we have this information wrote down, we first need to find the velocity, because once we do that, then we can calculate the height. Okay? So with this, find our final velocity from our acceleration formula. 9.8 equals our final velocity minus 0 divided by 5. Okay? So any sort of value subtracted, that's 0, that's subtracted from a variable or a number, is just going to give you the same value. So we've accounted for our initial velocity, so you could even erase that if you wanted to. So what we need to do is get velocity final by itself. We're not changing the value of this by cross multiplying. Doing this, 1 times VF just gives us VF equals whatever those two are times each other. And upon doing that, we've got 9.8 times 5. That gives us 49. 49 meters per second. But again, that doesn't give us the height of the building. That's just a part of the component. All right, so in this case, then, what we want to do is take this part of the problem, and since we know that we've got a velocity and we know we've got a given time, and we've got a time of 5 seconds, now we can solve for that distance. Okay, so 49 meters per second with 5 seconds, we can now solve whatever that distance of that height of that building would be. So in this case, we can do this. 49 equals our distance all over 5. Okay? So again, just like what we did here, some of you can skip this step if you want. We can put that over 1. 1 times d just gives you d then. So d equals whatever those two are times each other. So 49 times 5 give you approximately 245 meters high. And that's what we would be looking for. Kind of a two-step problem, but nonetheless, we'd have the ability to solve for that. So to make sure I don't have any issues with recording on these like I did earlier, we're going to see that this is going to be part 1 of a video. So I'm going to stop it now, and then we'll just, I'll give you you will have had the instructions tomorrow, so you know what video to look for. So we'll stop here and do some more examples in a separate video.